they all require some technique, mathematical formulas, more needs based on apart from concepts, just concepts. Simple question, but their statistics and mathematics problems are mostly straightforward. How do I can construct a hypothesis? When do I use it, or when do I use binomial? So it's more straightforward, and they're asking for the right way or procedure for approaching a question. So for the first problem, my whole team come up with a good solution. How do I construct a hypothesis statement, and how do I use probability values? The most important part is to know in statistics what we all feel is to know what's his background before approaching him with your own ideas. So saying him, for example, what do you know about hypothesis? So if he can come up with some data or his ideas on a sheet of paper or verbally, or giving some examples of his life example or something he remembers from the class, that can help you knowing and understanding his needs. Secondly, giving him some examples. Okay, if this is a situation, what do you think? What is exactly hypothesis in this thing? Second thing we come up with, building from the scratch. Now we have everything what he knows about hypothesis or the probability finding. Now we can come up with a solution. But as we just receive a training that our ideas should be with us, but we can exchange the views, or we can give more knowledge about the topic. So instead of just showing, oh, this is what it is, hypothesis is, we should construct steps-wise how to reach to the final solution he's looking for. So building on what he knows already. So he knows about, oh, hypothesis is this. Even if he's wrong, making that thing correct, then building next step, and reaching towards the final hypothesis. This is the part now we are shown he knows, that we think he knows about hypothesis. The important part is the second part, which is exactly as equivalent as what we did till now, which is making sure he has understood and he has sufficient resources to practice what he is looking for. So suggesting him about the resources he has, he can solve some practice problems he already got, he can solve the assignments, it's already on the stats portal, he can work with the stats lab, or if he's still facing problem, he can go stats helping center and do some more problems there. At the end of the day, we can also test him, like give him a proper practice problem and tell him to, hey buddy, would you mind solving it for us? So if he solves it, so that's pretty nice. So this is the one kind of thinking we thought it's a good approach. For the second question, which is, it's so cold here, I don't know why. Yeah. When do I use a bar graph versus a frequency histogram? So again, it's more about visual problem. What is a bar graph? What is a histogram? If he can come up with some ideas, some views, like, oh, I think this is bar graph or this is histogram. Instead, stopping him out saying, oh, no, I tell you what it is. So you just right away you break his thinking and all thought process he was having in his brain. Or the problems, actual key problems where he was struggling, we stopped that thought process. So instead of stopping him, what's his thought process, what exactly his problem, let him explain what he wants to say first, then give the opinion. Making it short, our group come up with some kind of hierarchy or.
Oh wait, not those markers.
Oh, yeah.
Oh, okay, sorry, I was so afraid someone was going to use it.
Those from academic learning, but not.
Thank you. Sorry, I thought you.
I understood. I did that thing in my actually slides, and it was perfect.
I've done that too.
Yeah. So all this. Is this point is visible to you guys? This
No,
point?
use it darker. The last one worked okay. I'm like way over here, the left is left.
So the only thing, every agenda for every student who will be reaching any tutor is he needs a solution. Solution to his problems, to his questions, to his anything, strategy is lacking a strategy, he needs a solution. So approaching a solution, what we thought is most important factor is first step should be knowing the background. So if we know what students knows, it is your half job is done, because now you know what exactly you want him to know from this. So second step would be the resources. So a student is next to you saying, what is the difference between bar graph and a histogram? Has he even studied anything which was in the notes given by Dr. Lastra or anyone? Has he even gone through with the assignments which was given by the stats department? So he should know about the resources first. And Ibrahim just mentioned to me when I was just coming, the most important factor for a student to come up with everything is, and even in our training, is sharing your experience. So you can share your experience, how you, when you were taking this course, what approach you used, or how difficult it's going to be going further. For example, the statistics course is just started, how exactly the course is, what the level of difficulty it goes, how you studied, something like that. It helps a student. It helps me still, because when I meet some prof, then they sometimes say, oh, you have to struggle more for this course. That gives me a heads up. Yes, I need to give more time now to build my foundation, because it's going to be more hard. So it helps students. I've observed it personally. So once you make sure, okay, now you come up with all the resources for you, not for the student, and you started approaching towards the solution what he needs. The second part we should work on after building the solution is coming up with the summary. If the student himself, or with a kind of collaborative learning atmosphere, we can come up with a summary, as we just seen in one of the training where they was working in genes, like BB and blue eyes and that. So that is a good approach, summarizing things in a more interactive manner. And as I just mentioned, once the summary is done, finalizing and testing whatever you have worked on for whole 1.5 hours with the student. So this is all as what we thought of.